We are doing Unit 2, Lesson 6 today, which is about a shortcut for knowing that two triangles are congruent. And so before we get to our notebooks, I want to show you this quick demonstration. I hope you can see here I have two congruent triangles. And I used some colors to help us see the corresponding parts. So these blue angles are corresponding. Right now they're both set to be 80 degrees. And the green angles are corresponding. They're both 70. And then I have these 30-degree angles, which are corresponding. And we also have these three side lengths that correspond to one another. So what I want to talk about today is I just want us to think about, do we really need to know that all three sides are congruent and all three angles are congruent in order to know that the triangles are congruent? And the answer is no. For one thing, I really only need two angles, right? Like if I have an 80-degree and a 70-degree angle, whatever's left from 180 has to be my third angle. So we don't really need to know that three sets of angles are congruent, because if two sets are congruent, then the third angles have to be congruent. And it turns out that we can even know less than that. So I want to take a look at what we have here. I've set up two angles. Okay, we've got the 70-degree angle and the 80-degree angle, and then we have the side between them, and that's really important. So it's not a side over here or over here, it's the side between the two angles that I have the same on both triangles. So I can increase the side length or decrease the side length. I can move these triangles around, do lots of different things. I can change the angles even. And you can see that sometimes, like if we do an angle like that, we're not going to be able to complete a triangle. It's trying to go the other way. We can't complete it. But you can see that if we do have two angles that can make a triangle here, let's not do 60 and 60. Let's do something like that. I'm going to be able to complete this triangle just by extending the sides in both directions until they meet. And so it turns out that no matter how big or small I make the triangle, if I have two sets of angles that are congruent, which I have here, 60, 60, 45, 45, and the side between them are congruent, there's only one possible way to complete triangle 1. I'm calling this triangle 1, right? Like if I extend them, there's only one place where those lines are going to meet, and it's right there. And no matter what I do over here, the exact same triangle is going to be formed, right? And as I change the angles, both triangles are going to change in exactly the same way. There's no way for me to create two different triangles if I have two angles, two corresponding angles that are congruent, and the side between them is congruent. And that's simply because there's only one way to complete this triangle, right? You extend this out, you extend this out, wherever they meet, that's your triangle. We're doing the same thing here. Extend it, wherever they meet, that's your triangle. And there's no way for me to create a second triangle given these conditions, right? Given an 85-degree angle, a 50-degree angle, and a side length of 3, there's only one way to complete that triangle. And so today's lesson is all about how if you have two sets of corresponding angles that are congruent and the side between them is congruent, that is enough information to know that you're dealing with two complete congruent triangles. Today's lesson is Unit 2, Lesson 6, and it's ASA, and those need to be capital letters when you write them in your table of contents. So go ahead and fill that out. Unit 2, Lesson 6, ASA, and then I will reveal what ASA stands for when you turn to a new page in your notebook. Go ahead and get this down, pause if you need to, write today's date, 2/6. And then the essential question today is, what does the ASA Triangle Congruence Theorem tell you about triangles? So we're going to sort of start by trying to draw what was demonstrated in the video that you watched just a moment ago. We're going to create an angle, a side, and an angle that are fixed. So I think we'll start first by creating a side, and I'm going to make my side 4 units long. So go ahead and do the same, 4 units. Let me zoom in here for you. And then I'm going to create a 50-degree angle. If you don't have a protractor, that's okay. You can just kind of eyeball it. But I'm going to make mine exactly 50 degrees just because I happen to have my protractor with me. So 50 degrees is right there. And if you don't have one, just do your best to make something kind of close to it. And then I want you to, using a straight edge, create a dashed line going that way. And then mark that that is 50 degrees. So we have an angle, a side, and then I want to make another angle coming off of the other side of my fixed line segment. And so here I'm going to make a 30-degree angle. And again, I'm going to use my protractor, but it's okay if you want to eyeball it. That's 30 degrees right there. And I'm hoping you can see that only one triangle can come out of this situation, right? Like if I do that, 50 degrees, 30 degrees with 4 units in between, there's only one possible way to finish the triangle, and that is by putting the third vertex right there. And so the key here is that if you have 2 triangles like this, 50 degrees, 30 degrees, and 4 units between them, they're going to be the same exact triangle. There's no other way to complete it. And so what I want you to write over to the side is that any triangle with 50 degrees, 30 degrees, and a side 4 units long between the angles will be congruent, meaning the same size and shape, to this triangle. So any triangle with 50 degrees, 30 degrees, and a side 4 units long between those angles will be congruent to this triangle. And so in the last lesson, we were like, oh, we need 3 corresponding angles and 3 corresponding sides, and it turns out you actually don't. All you really need are 2 corresponding angles that are congruent and the side between them to be congruent. And this is called the ASA Triangle Congruence theorem. So we're going to write that down super big and then make sure we know what all of those different letters stand for. So A, I'm making it big, A, S, A. This stands for, A stands for angle. The other A stands for angle. And the S stands for the side between them. Sometimes that's called the included side, meaning it's included between those 2 angles. And so the ASA Triangle Congruence theorem says that if 2 triangles have 2 corresponding pairs of angles and the side between them is congruent, then the triangles are congruent. So we're going to write all that out. It's a little much to write, but we're going to do it anyway. If triangles have 2 congruent angle pairs and the sides between them are congruent, then the triangles are congruent. It's a mouthful, but go ahead and get that down. And then we're just going to do 2 examples. This is going to be our first lesson where we do proofs. Proofs are really fun and really different and a bit challenging, and so we're going to do those in class together. I'm not going to have you do the proofs in a video. So what I want to do here is just a couple quick examples. So example 1, please draw these triangles. Okay, so pause if you need to get that down, but we have two right triangles here, and where you write all of the measurements is really important. So pause if you need to. But the question is, are these two triangles congruent? So we have a 40-degree angle and a 90-degree angle, a 40-degree angle and a 90-degree angle. So we have the AA part. The sides between them need to be corresponding and congruent. So over here we have 40 degrees and 90 degrees, and the side between them is 5 centimeters. So if that's the case on the other triangle, then we're dealing with congruent triangles. The problem is when I look over here, I have my 90-degree angle and my 40-degree angle, but the 5 centimeters is not between them. And so this triangle does not follow ASA. This would be AAS. So when you name them, you kind of go around sort of in a circle, A, and then the next item I get to is an AS. That's not ASA. Over here we have ASA. Over here we have AAS. And because they're different, they are not congruent. And the problem is that this is not between the angles. So here, even though they look congruent, they are not congruent. We're going to do one more example, and this one is going to be quite a bit harder. Example 2. So we're going to again draw two triangles, but this time they're going to be sort of connected. So what I'd like for you to do is draw, well, here, let's do it this way. We're going to draw a segment that's, let's go with 5 units long. And please use a straight edge if you have one. And then from there, we're going to basically draw like a parallelogram. I want you to go down 3 units and over 2 units, like that, and create an endpoint. And we're going to create another segment that's 5 units long here. Okay. So 2 parallel line segments is really what we have here, and I actually want you to mark that they're parallel. We drew them that way on purpose. And then please connect these and these to make your parallelogram. But this is a lesson on congruent triangles. So we're actually going to split this up into 2 triangles, and then we're going to see if those triangles are congruent. So go ahead and do that. Split them up into 2 triangles to see if they're congruent. And that's all I'm going to mark. So we don't have a lot of information here. We've got 2 parallel lines, and I want to know if I'm dealing with congruent triangles. And believe it or not, we actually have enough information to know that they are congruent. So we need ASA, right? Angle, side, angle. So what I'm going to do to make this hopefully a little bit more clear is I'm going to outline each triangle in a different color so that I can talk about them easily. So I've got my red triangle, and then over here I've got my green triangle. And there's something kind of interesting here, which is that the red triangle and the green triangle share a side. This side right here is in both triangles. That means they have a side that's congruent, right? This side of the green triangle, I don't know how long it is, but I know that it's the same as this side of the red triangle because it's literally the same segment. And so I'm going to put a mark there to show that those 2 triangles have a side in common, which means they have a side that's congruent. And so now I want to see if I can find any angles that are congruent. And the key to this problem is the fact that these 2 sides are parallel. Because if you think about it, I wish I had my highlighter handy. I'm going to grab it. Hey, this is a highlighter that someone gave me in class. So if you think about it, we actually have here two parallel lines and a transversal. Do you see the transversal? We have two parallel lines and a transversal there, and that means I know something about their angles. So I want to look for some alternate interior angles, and I can see that this angle right here, that's congruent to this angle because they're alternate interior angles. Do you guys see that, I hope? There's another pair of alternate interior angles as well. And that's because these two lines here also are parallel. So we've got here more sets of alternate interior angles. Those are also congruent. So over here I have angle, side, angle, right? One loop, one tick mark, two loops, and I have the same here. One loop, one tick mark, two loops, angle, side, angle, angle, side, angle. And that's enough for me to know that these are parallel. So we're going to, are congruent. So we're going to say congruent by ASA. And then I just kind of want to show here that we've got that angle, the pink one, the green one, and then the side that was one, oh, you can't see that, the side that's one tick mark. This is really challenging, but this is what we're going to be doing pretty much for the rest of the unit, is taking these diagrams and really trying to use logic and what we know about angle relationships to look for congruent triangles. So please take a moment, write a summary. The essential question today was, what does the ASA Triangle Congruence Theorem tell you about triangles? So do your best to write a summary, and then you're done.